In the last videos, we covered what is importance of NumPy. NumPy basic introduction we covered, and then how to create NumPy arrays, creation of NumPy arrays. Almost around 10 ways I covered, 10 different ways we covered. Okay, once a NumPy array is ready, how to access, how to access elements from NumPy array, how you can access elements from NumPy array. Okay, like we covered. So here, if you want to access only one element, yes, what is the way? How you can tell? Sir, can you please tell? Directly indexing concept. Sir, to access multiple elements, but in order, which are there in order to access ordered multiple elements, multiple elements, then we require to go for slicing concept. Okay, like next unordered, to access multiple unordered elements, multiple unordered means arbitrary. So one element is available at the top, second element is available somewhere in the corner, like arbitrary elements. Okay, like are to access elements based on selection. Okay, to access elements based on some conditional based selection. Yes, how you can? So this one is advanced indexing concept we will take. Next, and after that conditional based selection. Conditional based selection is also possible. For that we use the syntax sir, here condition, whatever condition we can take. Okay, like yeah. So can you please confirm all these concepts are very clear for you people, right? In the last sessions I explained very clearly, right? Okay, so next what array is ready, how to get the elements clear, right? Sir, I want to perform some operations on the arrays, not only okay, just retrieve elements. I want to perform some arithmetic operators, or I want to manipulate elements. Okay, like there are the remaining part is performing operations on these arrays only. Okay, yeah, the part of that. First thing what I have to perform, arithmetic operators. Okay, arithmetic operations on arrays. Okay, arithmetic operations on arrays. Okay, like sir, here, so which operators are called arithmetic operators? Okay, the following are various arithmetic operators available. The following are various arithmetic operators available. Various arithmetic operators available, right? So what are various arithmetic operators what we had? Okay, like sir, can you please confirm? Plus, minus, multiplication, division, okay, modulo, next, and after the division, modulo. Have you remembered, right? These are things also. Okay, like these are two things also, Python arithmetic operators. I hope, I'm not sure how many people remembered these things, right? Okay, the following are various arithmetic operators, right? So plus means can you please tell what is this one? What is this one? Addition operation. Okay, sir, minus means subtraction. Okay, subtraction operation. Next, sir, here multiplication operation. Next, here what this one's division operator. Next, this one is by default considered. Yeah, yes, anyone, can you please guide, sir? I forgot. Anyone, can you please tell what is this division? This division, okay, is by default considered floor division. Okay, floor division. Okay, like next, this one is by default considered, yes. Okay, here modulo operator. Modulo operation or remainder operation. Array, if I divide the given number with what is the remainder? Remainder operation some people may use. Next, this one is called exponential operation. Or some people may use power operator. Power operation. Okay, like sir, can you please confirm total how many arithmetic operators are there? These are various arithmetic operators available in Python. Remember that, right? all these arithmetic operators happily applicable on the NumPy arrays also. Okay, for all these operators, we can apply on NumPy arrays all these okay. So all these Pythons arithmetic operators operators are applicable on NumPy arrays also. NumPy arrays also. Okay, like sir, happily we can apply these operators on NumPy arrays. There is no problem at all, right? Okay, sir, here two things I have to explain for you people, right? What is the first one? So up to this, can you please confirm? Any doubt, any explanation is required? Please respond. Just 1 minute. Any doubt up to this concept? Okay, just we listed what are various arithmetic operators are there, like sir, any explanation is required about any explanation is required about these two things. What is the difference between these? What is the difference between this one and this one? Can you please confirm? Because if you already aware, okay, I don't think what is the difference between this one and this one, sir. So here normal division operator always going to perform arithmetic float operation only. Remember that it's always going to return float value only. But this operation can perform. So integer based division operation. Next float based, it can return okay int value, it can return float value also based on our requirement, but it's always going to return floor value only. Floor, suppose 3.9 is there. What is the floor value? What is the floor value? Floor value of 3.9 is a 3.0 or 3. Okay, like if it is the int 3, if it is the float, okay, 3.0, something like you can use. Floor means previous rounded value. Okay, even sir, here 3.9 is there. Okay, seal value for this is 4, sir. Floor value is 3. Floor means before. Ceiling value means seal value means next. Okay, like in several languages also we had this type of things, sir. Okay, just here let me take one small point about this one, sir. The result of division operator. Sir, here this division operator is always float. Okay, the result of division operator is always float. But floor division operator okay can return both the integer and float values. Float values can return both integer and float values, right? If both arguments are int, the result is always int. Okay, so if both but floor division operator means this one, sir. Okay, like now if both arguments are int, both arguments are of type int, then so floor division operator returns int value only. Okay, if at least one argument is float type, then it returns float type only. Yes, here observe. Are you feeling the difference between these two things, right? Not required to explain. Already we had in our Python sessions, right? Array this operator is always going to return float only, but this operator is going to return either float or int based on our requirement, right? Okay, well, suppose here I'm taking just a print of 2 by 3. Okay, sorry, 3 by 2 I'm trying to take, sir. 3 by 2 I'm taking. So can you please tell what is the output by default we are going to get, right? Anyone please confirm? 1.5. correct, right? Because this person is always going to return. This person is always going to return float value only. But the same thing you can ask, what is the answer by default? We will get 1 only. 1 only. 3 by 2 is 1.5, but 1.5. Okay, so floor value I should require to consider. Floor value is 1. Why I'm getting 1? Because both arguments are int type. Remember that. If I can take 3 by 2.0 or 3.0, 3.0 by 2, sir, now you are going to get 1.0. Clear, right? Any explanation is required? Can you please confirm so that you people can understand very easily, right? Now observe, first time 1.5, second time 1, third time 1.0 we are going to get. Okay, like next here if you observe, print 4 by 2, 4 floor division by 2, floor division by 2, 4 okay, 4.00 floor division by 2. Sir, 4 by 2. Anyone, can you please tell what the answer we are going to get? 4 by 2. What answer we are going to get? Can you please confirm? Yes. Okay. 4 by 2. What the output by default we are going to get? 2.0. Yes, remember that. Sir, normal division operation is always going to return. Okay, it is the float value only. But floor division. Okay. 2 sir, floor division, because both arguments are int type, that's why 2 sir. Okay, now I'm trying to take, can you please confirm what is the answer we are going to get? At least one argument is the int type, float type, then the result is always float. Okay, now not required to keep any explanation about this terminology, right? Okay, observe that. Yes, am I getting the same? 4 by 2, 2.0, 4 power 4, okay, like yes, 4x like this one, right? 2.0, like, yeah, clear? All the people are in the position to understand. Sir, what arithmetic operators are there in Python? Okay, what is the behavior? Only twist thing is this one. The remaining things are very easy for you people, right? Okay, well, sir, next one more small example just to get basic idea, because in NumPy you should not ask any doubt about this functionality, because once this functionality is clear, then we can go for okay remaining things, right? Now, okay, here just I'm trying to take just here one. Okay, here just observe that my requirement is, sir, print 10, okay, 10 plus 2, okay, 10 minus 2, normal operations, 10 minus 2, next 10 into 2, 10 into 2, okay, 10 into 2, next 10, okay, sir, what floor normal division 2, 10 floor division 2, next 10 modulo 2, 10 modulo 2, 10 modulo 2, next 10 sir, here exponential 2. Yeah, please confirm so that all these operators I hope sir now we are getting clearly. Happily we can move to the NumPy like you are to tell. So can you please confirm 10 plus 2, what about its value? 12. Sir, now 10 minus 2, its value the 8. 10 into 2, its value the 20. Next 10 by 2, 10 by 2 by 2, its value is 5.0. 5.0, remember this one. 10 by 2, its value the 5. Okay, 10 percentage 2, 10 percentage 2, its value the 0. Its value the 0. If I divide the 10 with the 2, what is the remainder? 0 is the remainder. 10 okay, 10 power 2, 10 power 2, its value the 100. Okay, if you want you can ask these things directly here. Okay, or you can execute this program, no problem at all. Yes, both the things are same. Yes, can you please confirm every time am I getting my expected result or not? 12, 8, 20, 5.0, 50, 100 by default we are going to get. That's all, friends. So Python arithmetic operators, you people should not have any doubt. Clear, right? Yeah. Okay, so next here there is one more small point. Of course at that point I will take it. So all these Python's arithmetic operators happily applicable on NumPy arrays also. Okay, Now, so just let me talk about arithmetic operators for NumPy arrays, with scalar. Okay, for NumPy arrays with scalar like. Sir, it is a technical word from the NumPy documentation only. Scalar. What is the meaning of scalar? Scalar means scalar means constant value. Scalar means constant numeric value. Constant numeric value is called the scalar. Okay, you not unidirectional and so on. Just here scalar means scalar means constant numeric value is called a scalar. Don't think too much. Array here. So I have an array is there a plus 2. That's all. This is what is the meaning of this one is we are performing arithmetic operation plus for the array. But with which values are scalar values. Scalar means constant numeric value. Beyond that, nothing, sir. Okay. Now, all arithmetic operators happily we can apply. So on the NumPy arrays with the scalar, right? All arithmetic operators are applicable. All arithmetic operators are applicable for NumPy arrays. For NumPy arrays with the scalar value. NumPy arrays with the scalar like scalar means already you people aware. So now let me take example for 1D array. Okay, just a 1D array example. 1D array example for 1D array, right? So now here just take a bit special care. Don't think too much. It is a very easy. Nothing. A school kid also can understand this. Nothing. You are not required to break your heads to understand this one. Okay. Don't worry much about this. So now I have an array is there, sir. Okay. Now this is my array. Assume. Sir, now which values are there? Okay. 10, 20, 30, 40. 10, 20. Okay. 30. 10, 20, 30. Next 40, 50 is there. 40 and then 50 is there, sir. Sir, total how many values are there? 5 values are there. Sir, simple. Assume that it is the int. Int array, sir. Array. Okay, like how you can create this array, you know, right? Now. So what will happen in this case? Now observe that a into 2. What will happen in this scenario is observe carefully about this one. Observe carefully. Okay. Here a into 2. Anyone can you please tell what will happen? Every element present inside array will be multiplied by 2. So this 2 will be broadcasted to every element of this array. Then automatically my array will become 10 into 2 20, 10 20 into 2 40, 30 into 2 60, next 40 80 and then 100, 80 and then 100. Okay, like can you please confirm any explanation is required about this one? Respond. Any explanation is required about this one? Sir, similarly a plus 2, a minus 2. Sir, a by 2, a floor division 2, a star 2 already we used a. Okay, so a star 2, a modulo 2 you can take. Next a floor division 2, like all these things, a power 2 happily you can apply all these operators, no problem at all. So what is the meaning? What is the result we are going to get? I hope everyone can expect the results. Correct, right? Everyone can expect the result. Yeah. So not required to keep any explanation about this one. Okay. A into 2, a plus 2. Array add 2 for every element. A minus 2, a by 2, a. Okay, like we should aware, right? Okay. 1 minute, sir. Let me take this example directly here. Okay. Now my question is a is equal to np dot array. You can take either any function, but I require an array. Okay, 10, 20, 30, 40, 50. Okay, like I had, this is the NumPy array I had. Now a plus 2. What is the answer we are going to get? Okay, a into 2. What is the answer we will get? A minus 2. What is the answer we are going to get? A divide by 2. Okay. A, sir, floor division by 2. Floor division by 2. A modulo 2. A modulo 2. 2. Okay, like A, sir, here power 2. Okay, A power 2. 2. Like, yeah, please confirm everyone in the position to understand this. Any explanation is required? Array, plus 2 means every element will be incremented. Into 2 means, okay, like, sir, this is arithmetic operators, how you can apply, okay, on the 1D array. Yeah, can you please confirm? Any doubt? Okay, yeah, power 2 means internally it is going to be considered into 32. If beyond that range is there, automatically typecasting is going to be happen. Remember that in these cases, boss, D type it is telling explicitly are the intertype. Okay, next, how to perform operations on the specific element? You can do that. Just these are on array directly. If we can perform operations like this, sir, on the specific elements also you can do the operations, no problem at all. You know, right? A of 0 by 2, A of 0 into 2. Okay, like Deepak, clear? Next, sir, is these operations are applicable on 2D array or not? All these arithmetic operators are applicable for NumPy arrays with a scalar. Okay, so all these Python's arithmetic operators are NumPy NumPy arrays also. So for NumPy arrays also, and for all dimensions applicable on any dimension NumPy array. Any, yeah, here like. So for all the dimensions, similarly, we can perform operation. Similarly, we can perform operations on, okay, 2D array on any other dimension arrays. Any other dimension arrays. Okay, like, yeah. So just let me take example 2D array. I want to take, sir. 2D array. I want to take. Okay, this is example 1D array. Of course, 3D array, 4D array is always the same. So just observe carefully, right? A is equal to np dot array of, okay, like I'm trying to take here just 10 comma 20 comma 30 comma 40 comma 50 comma 60. Okay, like I'm taking, yes, this is my nested list. With this nested list, can you please create an array A? If I can take, is it a two-dimensional array or not? I respond, is it a two-dimensional array or not? Yes. Okay, like, sir, actual values of array are not changing. Why? Ashish, here after performing these operation, you are creating a new array. That new array is going to be resulted. Original array, I'm not performing assignment, right? Have you observed? I'm not performing assignment. A is equal to A plus 2. Then automatically now perform A plus 2 and then assign to A. Sir, all these are new array objects or not? Please confirm. All these things are new array objects or not? New array objects. Okay, in the existing array operations are not going to be happen. Remember that someone is asking, sir, after performing these operations, but my original content is as this. Yeah, with these required operation, you are creating a new array. Okay, because end arrays are mutable or immutable? Mutable or immutable? Mutable. Okay, like, of course, here we are performing operations, right? Okay, with these operations, an object is going to be created. A is equal to A plus 2 if you can take. A is equal to A plus 2 if you can take, then automatically it will be there. Okay, now 2D array is right. Yeah, 2D array is ready. Now observe A plus 2. Okay, every element added or not? Every element added, every element of the array added by 2. A by A minus 2, A minus 2, A into 2, A by 2, A by 2, A floor division 2. Okay, A, sir, here modulo, A modulo 2. Okay, like A, sir, what is the power 2? A power 2. Okay, like yes, sir, this is. So please confirm. I hope everyone in the position to understand how you can apply for the 2D arrays. Okay. Similarly, you can perform operations on the 3D array also. We are not required to worry. Yeah. Clear? Arithmetic operations on the NumPy arrays. So a plus 2, what will happen? A minus 2, what will happen? Okay, like whether A is the 1 dimension, 2 dimension, 3 dimension is the same. Similarly, we can perform operations on any other dimensional arrays, any other dimension arrays. Okay. Yeah. So can I go for next point? All these operations are okay performing with a scalar. Okay, not between two arrays. Performing an array with a scalar. Scalar means constant value as per documentation only. Otherwise, sir, this concept is called broadcasting. No, broadcasting is a different concept. Okay, but origin for the broadcasting is this concept only. Okay, next level is the broadcasting. But what is the need of that? Here I have to tell some problems. Okay, to overcome these problems, we require to go for broadcasting, which is the bigger utility in the NumPy. Okay, so up to this, what we covered, arithmetic operations for NumPy arrays with the scalar, with the scalar, like we covered, right? Okay. Now the next concept what we have to take, arithmetic operators for NumPy arrays, for NumPy arrays with the arrays only, with the arrays, with the arrays only. Like okay, don't worry. Here also we are not required to worry. Arrays with arrays, with arrays. Okay, I'm trying to perform operations. Arrays with arrays only. How we can do this one, sir? Okay, like yeah, sir. Just observe carefully, sir. It's a very simple, very simple to understand. So, sir, are you facing any difficulty to understand this? Yeah, are you facing any difficulty to understand this? No. Then automatically next time also you won't get any difficulty. A school kid also, I mean nursery level student kid also, sir, can learn. Don't worry at all. Okay, like sir, here there is before this array with arrays, here there is one small point I have to conclude. Sir, just let me talk about this one. What is that point here is? Observe carefully, right? So suppose in Python, okay, in Python, division by 0 is not possible. In Python, division by 0 is not possible. By mistake, if we are trying to perform division by 0, immediately we will get okay 0 division error. Remember that. Okay, in Python, okay, 0 divide by 0 is not possible, so if we are trying to perform, then we will get 0 division error. Okay, like sir, 1 minute. Now I have print 10 by 0. Print 10 by 0. Okay, print 10 or 0 by 0. I'm trying to take 0 by 0. Print 10 by 0. Print okay, sir, like if I can take 0 by 0 or 10 by 0, like anywhere 0 division error is there. Then automatically, yes, what is the answer by default? We are going to get 0 division error. 0 division error divided by 0. 0 division error divided by 0. Something like 1 minute. Let me show these two things, and then error we can take. Don't worry at all. Sir, can you please observe that division by 0? Yes, 0 division error, division by 0 we are getting. Have you observed? 0 division error, division by 0. Even in the second case also we are getting the same. Any doubt? Yeah, respond. Okay, the people who are coming from Java, Java behavior is the different, Python behavior is the different, especially in this case. Okay, in Java, what the behavior is, 1 minute friends. Okay, here in Java, suppose if I can take sir 0 by 0, 0 by 0. If I can take 10 10.0 by 0, 10.0 by 0. So 0 by 0 in other languages, I mean in integer arithmetic, we are always going to get arithmetic error 0 divided by 0, something like that. But arithmetic exception we will get in Java. But in floating point arithmetic, okay, we never want to get 0 division error, or we never want to get arithmetic exception. If I execute this one, what is the answer we are going to get is observe 0 by 0. So here just take a bit special care. 0.0 by 0, 0.0 by 0. Sir, 0.0 by 0 means undefined. Can you please tell? In the normal mathematics, 0 by 0, 0 by 0 is always undefined. To represent undefined results, our languages have some facility to define. What is that facility? Here, N-A-N. What is that, sir? Can you please tell? N-A-N, not a number. It is undefined, to represent undefined values, right? So NumPy, this person is also following same style. If the result is undefined, okay, we never want to get 0 division error. We will get undefined, means N-A-N. Remember this carefully, right? Okay, but in NumPy, with respect to the arrays, if we can perform this, in the case of NumPy arrays, if we are performing 0 division error, okay, 0 by 0 divided by 0 case, we never going to get error. We will get N-A-N. Any doubt? Are you getting the point, right? There is a small difference there between NumPy and normal Python. So take a bit special care. Similarly, if I can take 10 by 0, in Python, it is always 0 division error. But in the normal mathematics, anything by 0, it is always infinity. Anything by 0, it is always infinity. Do you know, right? Infinity like that. In the case of NumPy also, it is not going to rise a 0 division error. It is going to rise, it is going to print, it is going to consider INF, which is nothing but infinity. Remember that. What is that, sir? INF, which is nothing but infinity. Okay, like that. So now, but in NumPy, we won't get 0 division error. We want to get 0 division error. If the result is undefined, means 0 by 0, okay, 0 by 0, then it is treated as, then it is treated as NaN. What is the meaning of NaN? Anyone can you please tell? Not a number. Undefined result, right? Okay. Next, if the result is infinity, then it is treated as INF, which is going to represent infinity only. If the result is infinity, when we are going to get infinity, 10 by 0, anything by 0, then it is treated as INF. INF means infinity only. INF means infinity only. Have you observed, right? We won't get any 0 division error. But in NumPy, we won't get 0 division error. If the result is undefined, then it is treated as NaN. If the result is infinity, then it is treated as INF, but not 0 division error. Where is the proof for that, right? So you people may ask, okay, example for that. Can I go for example? Yeah, please confirm. Can I go for example? Okay, like, yeah. Now take a bit special care. A is equal to NP dot a range are, sir, 6 I'm trying to take. Then which elements are there? Then which elements will be there, sir? 0 to 5. 0 to 5. Okay, like, yeah. A is equal to 0 to 5. Now here just a single short A by 0. A by 0. Now observe that. So A by 0. 0 by 0. 0 by 0. Actually, in Python, 0 division error. But in NumPy, NaN. 1 by 0. 2 by 0. 3 by 0. 4 by 0. 5 by 0. What will happen? What will happen? So 1 by 0, 2 by 0, 3 by 0, and so on. We never going to get any error. Okay, like, but warnings it is going to tell, hey, you are doing some operation, man. Warnings it is going to provide. Don't worry, sir. Okay, if we are not okay printing. If you assign some to the variable or line, maybe a chance warning. So array, what is the output by default you are going to get is NaN. 0 by 0 is the first case. INF will be there. Any doubt? Feeling comfortable? In the normal mathematics, okay, I mean in the normal Python, in the NumPy, with respect to the operations, there is a big difference is there. That's what you should aware. Generally divide by INF, we are not going to do that. Okay, but how to represent INF? Is the Python data type, is it considered as so NumPy data type or not? We have to check the. Okay, INF. Sir, have you observed, right? Is not going to be treated. Is the NumPy having that type? np.inf. Yes, have you observed? Have you observed, right? A by infinity is treated as the 0. Anything by infinity is treated as 0. 0. Okay, like yeah. Anyway, meaningless. So this is any number by divide by infinity itself is always treated as a 0. Yeah. So this is one small extra point what you people should aware, sir, with respect to arithmetic operations. Any doubt? Any doubt up to this? Okay. Now, arithmetic operators for NumPy arrays with arrays. With arrays means arrays with arrays. Sir, earlier we performed array with a scalar. Okay, array with a scalar value. Okay, like. But now array with array. Sir, both are arrays only. How you can do that? How we can do that, sir? Sir, very simple. Very simple. Here, say this one. I don't think you people are going to get some difficulty to understand this one. Okay, now I'm trying to do something like, okay, here just observe carefully. Observe carefully. Here 100, 200, 300, 400 I'm taking. Now listen carefully about this one. 100, 200, 400. Okay, like I'm taking. We'll get into 0 if we use. Yeah, sure, correct. But what is the need of performing that operation? I don't think it is commonly required. Divide by infinity. Generally, in the mathematics may be required, but in the programming, very rare. 100, 200, 300, 400 is there. Okay, this is my array, sir. This is my array. Okay, like now I want to perform arithmetic operations between A and B. A and B. Assume that, sir. A and B. Okay, like. So if I want to perform arithmetic operations between A and B, between A and B, okay, like, sir, what may be the result here? Assume that it is the B, 10, 20, 10, 20, 30, 40, like you can consider 10, 20, 30, 40, okay, like. So A plus B, is it acceptable or not? Can you please confirm? A plus B, is it acceptable or not? Yeah. Why not? Why not? In this case, what will happen is 100 plus 10, 110. Okay, 110. 200 plus 20, 220. 300 plus 30, 330. 400 plus 40, 440, we are going to get. Similarly, a minus b. Is it possible to perform or not? Yeah, why not? Why not? Okay, like a into b, all the remaining operations happily we can do. I don't think you people are going to face the problem. Even for two-dimensional arrays also. Okay, like for two-dimensional arrays also. So for one-dimensional arrays also, array with array operations are always applicable. Okay, like 1 minute. Arithmetic operators for NumPy arrays with arrays. For arrays with arrays. Okay, like so very simple, very simple operation, right? Now have a look once. Let me go for a small chota example for that. Okay, a is equal to np dot array, okay, 100, 200, 300, 400. Okay, like a b is equal to np dot array, okay, like np dot array. Now here just observe 10 comma 20 comma 30 comma 40. I'm trying to take, yeah, a and b both arrays are ready. Now a plus b, yes, a minus b, a into b. Okay, a divide a by b, a floor division b, a percentage b, a power b. Yeah, here take very special care. I want to tell something. A power b. A power b means 400 power 40. Array 100 power 10. 100 power 10 means you know already. 100 power 10. Now observe that. Now observe here. Have you observed it? Something like we are getting some values. We are getting some values. What happened here is yes, take very special care. Whenever we are performing arithmetic operations, power operator, it is telling that boss my type is 32 only. If it is going to exceed 32, then the value will be rounded to 32 only. Okay, remember that. That's why we are getting 000 zeros in these cases. Feeling comfortable, right? Yeah, why we are getting? Because so the values are not in the scope of 32 bits. It is beyond that. Then the round operation is going to be happen. The extra bits by default will be removed. Only 32 bits are going to be considered just for those 32 bits. Okay, this value we are going to get. It is, that's why it is telling boss, I consider only 32 bits. Boss, I consider only 32 bits. Okay, like it is telling clearly. Okay, more than 21. Deepak, 21, 47, 48, 36, 47. The values are more than 21, 47. Have you remembered that our childhood somewhere we covered 21, 47, 48, 36, 47. This is the max value which is represented by using 32 bits. If the value more than this number, then automatically the extra bits by default will be removed in the memory. Okay. Any doubt? Are you feeling comfortable, right? Okay. Now here just observe carefully. Observe carefully about this one. Yeah, here there are two doubts is in your mind, rounding in your mind. There are two doubts rounding in your mind. Okay, like 1 minute. Don't worry at all. That part I will take care. Okay, sir. Here this is my array A. Okay, like now A plus A minus A into A. Okay, A by A floor division A. Next A modulo A power A. Okay, like I'm taking sir A power A. Okay, like 100 power 100, 200 power 100. Okay, like sir, any explanation is required about these two examples. Can you please confirm? Okay, how the operations are happening like this is even on two-dimensional arrays also we can do that. Okay, no problem at all. Even on two-dimensional arrays also we can do. But here one small doubt is disturbing our mind like anything. It is killing our brain. What is the doubt is, sir, if the arrays are of different length, if the arrays are of different shapes, are different sizes, are different dimensions, how we can perform array operations? Are you getting the point, right? Yeah, this is the bigger doubt for most of the people, right? Okay, so one array is one dimension, but second array is the two dimension, or one array is both arrays are two dimension only but a different lengths. Okay, both arrays are two dimension only but different shapes. How you can do that? Okay, for that next level concept is broadcasting. Remember carefully, right? Array for that next level concept broadcasting we have to talk. Okay, as of now, to perform operations like this, okay, to perform operations like this, both the arrays should be same dimension, same size, same shape. Remember this one, otherwise we will get error. To overcome this problem, we should go for broadcasting concept. Remember carefully about this. Okay, but what is broadcasting? Don't ask me, even I too don't know. I will discuss. Okay, like yeah, can I go to the next level or not? Yes, can I just let me perform some operation on the two-dimensional array? Okay, let me perform operation on the 2D array. How you can do that, sir? Sir, now a is equal to np dot array of 10, 20, 30, 10, 20, 30. Next, 40 or otherwise, let me take 1, 2, 3. Next, 4, 5, 6. 4, 5, 6. Like I'm trying to take nested list. With that, I'm creating an array. Yes, sir, this is. So a plus a plus a plus a. Have you observed, right? 1 plus 1, 2 plus 2, 3 plus 3, 4 plus 4. Okay, like a minus a, all zeros. A multiplication a. Okay, like a by a. Okay, a modulo a. Okay, a modulo a. Sorry, a floor division a modulo a. Next, a sub power a. Yeah, perfect. Now, have you observed all the values are within the range? That's why proper values only we are going to get. Okay, for multi-dimensional arrays also we can apply. Okay, like yeah, just observe that for two-dimensional array for any dimension. Okay, example 2D array. Okay, like, are you feeling comfortable? Any doubt about this one? Can you please confirm how you can perform arithmetic operations? Okay, now here just to perform arithmetic operations on arrays with arrays. Okay, to perform okay, to perform arithmetic operators for arrays with arrays or between arrays, operators between arrays, between NumPy arrays, compulsory both arrays should have, okay, should have, both arrays should have same dimension, okay, same dimension, same shape and the same length. Okay, length means size, same size. Okay, like clear, right? Otherwise we will get error. Okay, like so where is the proof for that? Now observe carefully. a is equal to sorry, a is equal to np dot array of here just 10, 20, 30. How many elements are there? Sir, only 3 elements are there. Okay, B is equal to np dot array of sir here 40 comma 50 comma 60 comma 70 4 elements are there, sir. Okay, like now observe a plus b. If I perform value error operands could not be broadcast together with the shapes. Have you observed? So similarly, you can perform a minus b. Array, every time in the same error by default you are going to get a into b everywhere, a into b. Okay, a by b, okay, like everywhere is the same problem by default we are going to get. Sorry, we could not broadcast with the shapes 3 4 because dimensions are same, but the problem is shapes there is a problem is there. That's why, right? Clear? To handle these type of requirements, we should go for which concepts are to handle these type of requirement, these type of requirements. We should go for I forgot. Anyone, can you please remind once? Broadcasting, how we can perform there, that part I will take care, don't worry. So arithmetic operators and the arrays, how we can do, okay, like it is a very clear for you people, right? Yeah. Next, one more thing, sir. One more thing. Yeah. One more note. Sir, here, if I want to perform arithmetic operator, okay, what symbol I use? Can you please tell arithmetic addition? What symbol I use, right? What symbol we use? We use a plus operator. Okay, instead of using plus, even function form is also there. NumPy module contain add function for that. Okay, add function for that. Okay, like so instead of using or for every arithmetic operator, NumPy array, NumPy library defines functions, equivalent functions, and we can use these functions also. Okay, like so if we have plus operator is there, equivalent function is np dot okay, equivalent function. If I can take a plus b, assume that's np dot add of a comma b, getting np dot add of a comma b. Similarly, the remaining set. So a minus b is there. Okay, multiplication b is there. Next, division b is there. Next, floor division b is there. Next, modulo is there. Next, and after that, okay, modulo is there. Okay, next we had the power. Okay, like sir, here add, second method is subtract method is there, subtraction. Okay, next multiply, okay, multiply is there. Next divide, sorry, multiply. Next divide, okay, floor division, let me check that. Mod operator is there, mod. Next power operator is there, but only thing is what is this one, we will talk. Maybe is there any floor divide? Okay, do you have some function or not? 1 minute, I will check. Anyway, don't worry, sir. We will check this one, sir. Okay, like so. Can you please confirm any doubt up to this? Yeah. Please confirm any doubt up to this. For every arithmetic operator, NumPy library defines equivalent functions. We can use these functions directly. 1 minute, sir. 1 minute. Here a is equal to np dot a is equal to np dot array of okay, here 10 comma 20 comma 30 comma 40. b is equal to np dot array of np dot array of, sir, here 1 comma 2 comma 3 comma 4. Okay, no problem at all. 1 comma 2 comma 3 comma 4. Yeah, here and b both are same one dimensional arrays, same shape. Okay, same length. Yeah, same type, same length. Okay, like now here here what I want to take is, so just np dot yard of a comma b I'm trying to take. What will happen? Is it working properly? Is it working properly? Okay, sir, np dot yard of subtract. Okay, subtract a comma b. Yes, perfect. Next, np dot multiply. Okay, multiply of a comma b. Yes, np dot okay, divide a comma b. Okay, np dot divide a comma b. np dot mod a comma b. Okay, like mod means next divide a np dot power a comma b. Yeah, can you please confirm all the things are clear, right? Yeah, Sonam, can you please tell what is the equivalent method? Anyone identified what is the equivalent method for floor divide? Yeah, Sonam, have you checked it right in the documentation? Let me check. np dot floor divide. Yeah, floor divide. Yeah, from the Google or documentation we can find it. I don't think floor divide a comma b. Okay, like that. Yeah, perfect. Floor division. Okay, like that. Yeah, np dot floor divide. Okay, like yes, these are various functions what we have. Floor divide. Okay, like now example. Okay, clear. Now all the functions I used, no problem at all. Okay, like so now if I can take np dot yard of a comma 1, is it going to be accepted or not? Yeah, why not? Have you observed? Why not? Why not? Like it is acceptable. Okay, like np dot yard of a I'm trying to take. Yeah, is it acceptable or not? A, is it our required answer? Is it our required answer? No, right? No. This is not our required answer. So means more than 2 arguments not working. np dot yard of a comma a. Yeah, a comma a is working properly, but a not working properly. Getting this NumPy, it seems to be very dangerous person. It is not telling, oh, this is the problem and so on. It is a very innocent person. It is ignoring the errors. Yeah, clear. What happened in this case? There is something is happening. Have you observed? There is something is happening in this case. There is some difference also there. Some difference is there here. Not missing something. What happened is Here listen carefully. Listen, there is something is there, some fishy thing is happening in this case. NP dot array of 10, 20, 30, 40. Yeah. B is equal to NP dot array of 1, 2, 3, 4. If I can take. Now observe carefully. A content, B content is okay. NP dot add of A, B. 11, 12, 33, 44. Let me print A. A is the same. Let me print B. B is the same. A value is the same only. Then why we are getting earlier 40, 80 and so on? NP dot add of A, A. Same. Have you observed, right? If I pass a 3 arguments, something is happening. A value also internally is changing. Okay. Internally, A value also changing. A plus A stored. And then what about A? Okay. So these are functions. Maybe we will discuss in detail somewhere. Don't worry. Somewhere we are going to discuss. Now observe that. A plus A is going to be happen. And then B. 1 minute. Already our powerful documentation is already there, right? Here internally broadcasting is going to be happen, it seems. Okay, what that part I will take care. Returns end array. Any number of arguments, any number of keyword arguments you can take. Array like input arrays, and array, none or tuple array, alternate array objects in which pair put results. And the array R will have the shape in X broadcasted to X. If output provided will be written, if not, R will be allocated to my combine, something like that. Accumulate something is there, I something is there, yeah. Okay, don't worry, in the next level we will talk, but instead of just aware up to that aware, okay, we are okay, just the number of arguments must be 2. No, okay, just the number of arguments is more allowed, but something is happening. Maybe next level we will get that, maybe in the broadcasting, like it is going to be clear. Don't worry at all. So up to this, any doubt? Are you feeling comfortable, right? How to perform arithmetic operators? Okay, with the scalar values, next array with array, how you can do that? Yes, it is very clear for you people. Okay, now, so next cinema we have to discuss that cinema itself is the broadcasting only. Okay, but before that, I have one small doubt is there. Sorry, and pay that array. Yeah, okay, yeah. No, 40, Yeah, here also different shapes. Okay, it is not accepting. Okay, but anyway, if there is any change is required in the next level, definitely we will do that. Okay, let me talk about broadcasting so that you people can fill if any gap is there here. That's it. Clear, right? So what we performed, sir, up to this? So we can perform arithmetic operations, arithmetic operations. Okay, how to do what are various arithmetic operators are there in Python? What is the behavior? Okay, next in NumPy arrays, how we can do that? Okay, like you people should be aware. Next one small point also I told, in Python divide by 0 is always zero division error, but in NumPy we are not going to get that error. Okay, like next, instead of operators, okay, you can call the functions also. Universal global functions are available in the NumPy. Happily you can call these functions also, no problem at all. That's it.